Hello, so I will now show you how to plot and display graded data from WaveWatch. So I'm using my IDL tool and we're just going to read some NetCDF output. You could also use the ASCII output from WaveWatch using this option here. I haven't used it in a few years, but it should work. So let's go with the NetCDF. So I'm going to load some file I have here on my external hard drive, which correspond to the runs for seismic noise sources, but it also has regular significant wave height and stuff like this. So I wanted to look at the year 2008. Here I go. So I'm going to take this wave height map, and you can find similar files on our FTP site. And you see that the variable now has a wave height in here, and then you can just choose to plot the W3 map. Okay, and here we have it. That's the contour. If you want to play with the contours, it's a bit slow, so I tend to prefer for fast exploration of the data to use a TV option, which is faster. And then, well, if you want to have some fixed maximum for the wave heights, let's put it at 15 meters. And fixed range. There we go. And so now if we scroll over time, so you can do that with the mouse, just slide the slider here, or with the arrow keys, go left and right. So here I'm going forward through time, and you can see the wave heights moving around. You can zoom in on different areas. Say we can look at Western Europe. Just select an area like that with just click and point on the arrow. And if you have a mouse with a wheel, you can just zoom in with the wheel and zoom out with the wheel, and the zoom will all be centered at the center of the image. So you can actually use this zoom feature to scroll along the map like this. You can see the effect of a Y. And zoom out back again. Now, if the plot region is a bit funny, you can also, here for example, have the color bar well separated. You can change these settings on the bottom here. So the BLX is the X limit for the plot, so like you can put it at 0.1, so you can go further to the left. The bottom stuff here, we can put it like that, and so forth. All right. Now that was the wave heights. A slightly different thing would be to use parameters that are also a function of frequencies. And so for the seismic noise, we do have these noise sources which are a function of frequency. Okay. And you can also on our FTP find the wave spectrum on the entire grid, and you can play with it in the same way. But for the noise sources, so this is a pressure induced by the waves at a very large wavelengths at the sea surface, and we can just refresh. Okay, now what happens is that's a function of the frequency. So if you just select the frequency range to be the full frequency range here, you have, okay, to refresh now, and of course the maximum here is now not so good, so let's just put it to 1. Okay, and then we saturate a bit the sources in this area. There we go. Now I was just showing you the plot with the null projection. Now it's actually hard to see there, the coastline and everything. You can load in some shoreline with the GSSH option here. The other thing you can do is to use the map projection tool with IDL map projection. So you just use a map projection. So the default is the orthographic grid, and yeah, so we can just move through time at different times. That's the end of. You have different projections and so forth. So that Sims, yeah, TV is a bit. Ooh, we're having some funny results here. So if we go back to the wave heights. Okay, so somehow for the wave height it's working alright with the projections. Don't ask me why, there may be a bug. So again, orthographic, and then you can scroll around the world. Seems that the map projection is having some problems with the frequencies, so okay, let's just forget these map projections. No map projection, go back to this, and we're gonna look at our frequency spectra of noise. Alright, so if you select the frequency range and then you update the variable, and of course the max is not good, so here we go. You're gonna zoom in on the West Pacific. So these are the map sources for sometime in, okay, we're going to the end of January, and this is one event that we actually studied in had a paper about that one, this one source of noise is due to swell coming from the Gulf of Alaska and wind seas going against it. And you can zoom in on different frequency ranges to see how these sources are different at different frequencies. Now if you change the frequencies, nothing happens because you have to reselect here the variable. I'm sorry for that, but and okay, so maybe now what I should do is to fit the range to the data, because it's, yeah. So that's for the lower frequencies, and you can see the different blobs of energy. If you actually go to even lower frequencies, you'll see this large band here due to some swell event, and it's fairly different. If you look at the higher frequency range, you'll see something which is closer to the shape of the storms and the winds. So this is how you can play with all that data and plotting using both parameters are not a function of frequencies, but also parameters that are a function of frequencies on the entire grid.